Okay, hello everyone, let's start. So, so we are on the ER model part. Okay, so in the previous session, we have just gone through a few points like in ER model. We have just gone through what's the entity, right? That's in real world object. Then we have seen about the attribute. In attribute, we have seen single and multivariate attributes, right? And after that, we have seen some information on simple composite attributes, stored derived attribute, key, non-key attributes, right, and required and optional attributes. So this is what we have covered so far. Attribute. Now it's all the relationship, right? That's the important part in ER right now. See the ER model, right? So far we have just covered in the relationship. We have different types of relationship. For example, we have binary relation, ternary, and n-ary relation. We call this binary, ternary, so based on the number of entity set we have. For example, if we have two entity set E1 and E2, right, they are all related with some relation. So we can call that as a binary relation. Now, when we call it ternary relation, we have probably three entity set, and each entity set is anyhow related with some relation. So it depends, like if the relation can be only one, or there can be equal number of relations equal to your equal number of entity set. In an array relation, we have n entity set, all are linked with each other with the help of one or more relations. Right. Now coming up to the relation we have in our ER model. Right. So what type of relation, or we used to call it as a mapping basically, right? So we have other different name. For instance, we have just seen what's the degree of relation. Sometimes we can call it cardinality as well. So in the books, you probably may find the degree of relationships or cardinalities mostly used, right? So now in this mapping, we have two different types of mapping, right? One is called your one, right? And it's denoted by an arrow, any either direction of this one, or it can be in this direction as well, right? So, and other is your many, right? So in many, we don't have any arrow, it's a line segment, right? It's a line segment is between your relation and the entity, right? So what's one part here? In this one, we have the entity allowed to make relate at most one other entity with other entity, right? So in one part, we have at most one relation. So basically at most means either zero or max one. Means what one entity can have either no relation, or it probably it can have only exactly one relation. And so far we have seen about many in the same time. Entity allowed to relate many other entities, right? So here many doesn't probably means it's not zero, right? So many here means zero or more, right? So 0, 1, 2, 3, and so on, right? Just like your n-ary relation kind of. So basically, the representation for this many part is just a line segment. Just think about that, right? And so for when we have also we have talked, when we have possibly the two events, right? It's one and the many. We have the two event, right? So what are the possible combinations we can form? That's 2 power 2. That's the norm basic maths. That's four. And what are those? One to one, one to many to one, and many to many, right? So as we have already seen this one in detail, right? Our main task is to form the candidate key probably in this all of the relationships. Now let's cover all these four relations we have in ER model one by one in detail, right? So just to save time, I have just written, let's say we take the scenario of student and project, right? We have two entities set, student and other is a project. The relation is your enrolled here. So basically student is enrolled in some project, right? So now let's start with one, that is one to one relation. So what happens in one to one relationship here, right? Okay. Now, as the attributes we have, you can see we have the roll number, name, and age of the student. But in the project, we have the project ID, project name, and the duration of project, right? So roll number and project ID are your primary key, basically, right? Primary key, as we have seen, these the key, or say the attribute, basically that identifies every tuple uniquely, right? So we take that as a primary key, and in any table there must be exactly one primary key, so we have seen. Now in enrolled table, that's the relation table, right? In relation table, as I told you, the relationship also forms a table. The thing is we need to minimize that, and if possible, right? So we have taken the relation table, and the attribute for the relation table will be the primary keys, right? The primary keys of either of the both of the entities, and basically the set that we want to relate each other, right? So okay, let's take some values in the student table. Let's say firstly S1, S2, S3, S4, and S5. Let's say uh, some name A, B, C. Uh, okay, acronyms. And the age, let's say 25, 24, and so on. The same goes for project. Let's say we have P1, P2, P3, and P4. Let's say the project is IoT, let's say data science, ML, some artificial intelligence. The course duration is, let's say 50, let's say 80, 60, and 90. Right. Let's say we have taken this data here. Now, the important thing is always remember what we will do is we will try to identify these two things in every type of relation that we will cover. The first one is what's the candidate key of a relation table? What should be the candidate key? And the other is, can we minimize the number of tables we have? For instance, we have three tables, right? So what's the possible minimum number of table in our scenario? Right, we need to take care of these two things, right? So now let's say now we are talking one-to-one relation, right? So what happens in one-to-one relation, as the name says, every entity, or say every tuple, or say the every student is related with one project. So we denote this like this one and one, right? So in a one-to-one relation, right? In one-to-one relation, basically the arrow is here, right? So one student is enrolled in one project, right? And on the other hand, a project can have a maximum of one student, right? So this is what it means to say with one-to-one relation. So how we frame this one with the help of this relation table. See, this relation table formation will ensure what type of relation basically you are doing between the entities, right? So one student can be in one project, right? For let's say we have S1 student. S1 student can be in project P, right? S3 student, let's say S3 student can be in project P3, right? Now, S2 student can not be in either P1 or P3. Basically, each student will be in some one project, right? Or one project will contain only one student. So let's say it is P2, right? And let's say S4 student is in project P4. There should be no repetition either of your column, or say the attribute in a relation table, right? One-to-one mapping is there. If you can just understand, like in function format, right? We have this. So there is a one-to-one mapping between each of the set, right? It doesn't matter, like we can have some non-related attributes here, right? This is the concept of participation we're gonna see later on. But the mapping will be on exactly one-to-one in between them, right? So in this one, so what should be the candidate key here now, right? So the candidate key, as we have seen, means the minimal super key that can uniquely identify tuples in your relation set, right? So now let's see about the roll number, right? Before that, always remember in this relation table, the attributes that we are using all your primary key of other entity set. And we used to say this as a foreign key, right? These are the foreign keys which are referencing to the primary key of entity set, right? So basically now identifying the candidate key for this one is, let's say take the roll number, right? So candidate key, as we know, the candidate key cannot be the null as well as it cannot repeats values. In the roll number, we can see there is no repeating values. As well in this PID, there is no repeating values, right? So in this case, when we are talking about one-to-one relation, our candidate key is either of roll number or project ID, right? You can take either of this one, right? Candidate key. So in this one, so we have seen what's the candidate key for the relation table, right? The next question comes out to find the minimum number of tables here, right? So what we can do is to minimize the number of table, right? What we can do is, we cannot, obviously we will not minimize this one. So what we'll do is we will try to merge this table, this relationship table, with any of these entities, right? So how we will do that? So for merging, right? So for merging, is it possible to merge the relationship table with either of this one, right? So yeah, in this case, always remember in one-to-one relation, we can merge this relationship table with any of your this one. Either this is your student entity set or say the project entity, right? You can merge in either of this one. How? Let's see. Okay, let's try to merge this relationship table with this student one, right? So with enroll and student table. So what we'll be having, our enroll table will have our roll number, which is the primary key. The name is, right, plus see the roll number. The values in the roll number are unique. As we have seen, the roll number can be the candidate key, right? So what we can do is, when we'll merge this table inside this one, the attribute which is present, right? We have the project ID will be merged with this table. So we'll have this project ID here, right? So this is what foreign key, because we got this from the different table, right? So now what will be the values here, right? So let's say for S1 student, we have the A is 20, and now S1 is enrolled in project P1, right? So that's here. S2 B 25, and the S2 student is enrolled in project P2. So in this way, we can see that we can merge all the values here in this student table. So for S4, we have A28 and S4 is in P4. Now see here the student S5, right? There is no entry for S5, right? So we can left this as a blank here. It means what? The student S5 is not yet enrolled in any of the project. This is what the table we have when we can when we merge with student table, right? So in the same way, we can either merge this enroll table with the project. Why? Because again, the project ID PID is the candidate key, right? And it, since the values are unique, you will add another attribute here for roll number, and you will write the corresponding student roll number with your project ID. Right? So P1 is in S1, P2 is in S2, in the same way. Right? So you can probably you can make the merge table for the same. Right? So here in one-to-one relation, how many total minimum number of tables we have? It's not three, right? We have, since we can merge this enroll one, so we have two only, right? So and two, one is for student, another is a project, and the relationship table is merged in either of this one, right? So now we can just think of your what? Let's say one to many relation now. One to many relation, right? So what will happen in one to many? This is one and this is many part, right? So in one to many, since one student, how will read, one student can enroll in many project, but a project can have exactly one student, right? So how we will design this one? Let's say the part remain the same, we need to design this table only, right? This one. So how we will make that? Okay, see now, the student, the project, this is 1 to m, right? Sometimes we represent this as a star also. So how this will look like, let's say we have the roll number and we have the project id, right? Just taking in the same data, take the same data for project and the student, we need to frame this one, right, in one to many. So as it says, one student can have many, can be enrolled in many projects. Let's say S1 is enrolled in your P1. So now S1 can enroll in, let's say, project P3 as well. One student is enrolled in more than one project. This is how the relationship is same. For example, we have S2 can enroll in P2 and same S2 can even enroll in P4 project, right? So this is how we frame one-to-many relationship table here, right? So now coming up to this one, what should be the candidate key for this one? Right. So you can see like in this one, right, since these both are the candidate key of different entities, for this one, can roll number be the candidate key? Obviously no, because see, we have the repeating values here, S1, S1, S2, S2. Since we know the candidate key should uniquely identify, there should not be the repeating values in that attribute. So roll number cannot probably be the candidate key. Looking at to the PID, project ID, since we can see that there is no repeating values, right? So for candidate key, we have the PID attribute only, right? So this is how we can identify the candidate key for this one. Now coming up to the next one, can we merge, right? Can we merge the relationship table with any of the attribute? Now look, when we talk about the merging part in your one to many relation, right? So always remember, obviously, just think of, you can just even visualize, we have the S1 values, right? In this one, here we have your roll number, let's say we have the name and is, right? We have the attribute S1 here, right? Let's say is something like this. But when you will try to merge this table with this one, you can see that S1 attribute, S1 tuple is having two values. So probably we know like that when we merge, we're gonna have a project ID as well, another attribute. And in this single tuple, S1 will contain two values, P1 and P3, right? So two values, right, in the same tuple, yeah, so, right, that's not possible, right, in the database. When we talk about the atomicity of this database, we cannot have more than one value in a single cell of your database. So that's why we cannot take this value, cannot take this roll number or say this table towards student. But yeah, we can see here we have, unique values in this attribute PID, which is probably the candidate key of this relation table, right? So we can merge this one with your what, project ID, project table, right? We can merge this one with this. So what will be the, and so why we can merge? Because since the unique values and every tuple will have exactly one value while when we merge them, right? So while merging, what the table will looks like, we have the project ID, project name, your duration, and let's say what your roll number, right? So coming out the values, we have P1, we have the P1, P2, P3, P4, right? And let's say it's IoT, data science, ML, AI, duration, as we can get the same data. Now, since P1, right? So filling the value of the roll number attribute P1 is in S1. Okay. P2 in S2, P3 again in S1, and P4 in S2. So this is how we can make the merge table of enroll with your project entity, right? So again, minimum. So for minimum number of tables we have here is not three, it's two here, right? So we can merge the relationship. Just for making, keeping this mind, right? As a short trick, you can just say, you know, um, you want to remember it for a long time. So what you can think of is while you are merging in 1 to M relation, you have to merge this relationship table towards many side, right? Remember this point. Since this is not the logic, but for remembering, you can just keep this thing in mind. The logic we have seen is we're going to merge this one towards the side which is having the unique values in the attribute, right? So project ID is a entity, or say the attribute of your project entity. So we're going to merge this with the project entity only, right? But you can remember, like, we merge this relationship table towards many side, right? Now, for your many to one relation, right? For many to one relation now. Again, just taking the same scenario, right? And this is just, same, right? You just change this one, the annotations here, one to many and many to one, right? But the concept will remain the same, right? For merging part only, right? So let's say many to one. Let's form this table first. And the merge part, obviously, you can, the merging part for this one will remain same. We have the roll number and project ID, right? So basically, uh, in this one, how we will read, right? So the student, many student can enroll in a single project, right? Many student can enroll in a single project, right? But a project can have, uh, obviously, right? Um, just So in many to one relation, right? In many to one relation, what it means is a project can have many students, right? A project can have many students, but there is exactly, every student is enrolled in a one project, right? So okay, understand, like this one. Let's say we have this roll number S1, right? S1 is enrolled in P1 project, right? Now S2 is enrolled in P2 project. But when we talk about S3 student, we can say that the S3 student is also enrolled in the P1 project, right? So the same project is having more than one student, right? So one project is having multiple student, right? But student is enrolled in a one project, right? This is how. And let's say S4 can be in, let's say, P2. So the project P2 is having multiple number, more than one number of students, right? So in this case, what will be the candidate key here? So you can just see the candidate key will be the unique part, the unique attribute that we are having here. So we cannot take P1 this one project ID as P1 is being repeated, P2 is repeating, but the roll number, this is quite unique, right? So we can take this as your candidate key here, right? While we are merging part, right? So when okay, towards which table we will merge this relationship table? As you can see in the previous one, we have seen towards the many side, right? So again here we will merge this relationship table towards many side. That's student here. Why? Because the roll number attribute in the student is, the candidate key for the relation and have the unique values, right? So we can merge this part here in this one, and here also the minimum number of tables will be two only, right? Now, the fourth one is your many-to-many relation. We used to represent this by M-to-N relationship, right? So, what used to happen here? Let's take the student and your project. So we have M and N. How we represent, right? It means what? A student can be enrolled in many projects, and one project can have multiple number of students, right? So how we will make this relationship table? Again, we have the roll number and the project ID here, right? Considering the same data, this one, right? Yeah, for the student and the project. Let's say roll number S1 is there in the project P1, right? Now, S2 student can even enroll in the P1 project. So basically, one project is having multiple number of students, right? Now, let's say S3 is in project P2. Now, same S3 student can even be in project P3 as well, right? Since multiple students, multiple projects can have the same number of students, right? So, okay, the other or we can what we can just say is same student is enrolled in more than one project, right? Many to many relation we can have. Now, this is very important for find the candidate key here for this one. Since we can see that if we take individually any of the attribute, can we say like only the roll number or only the project ID can uniquely identify the tuples here? No, because roll number have the multiple values, say S3, and the project ID also has the multiple values. So individually, we cannot say the candidate key, either roll number or project ID. But if we take both together, we can say that yeah, it uniquely identifies now S1 P1, S2 P1. So that's the difference, right? So roll number followed by plus your project ID. This is your what candidate key here, and this is what your composite key, composite attribute, composite key. Composite key means having more than one attribute in this, right? So this is the table formation. But now understand, can we merge this enroll table with either of the entity? Because as per the concept that we have seen right now, in order to merge the table with either of the entity set, this attribute, the candidate key basically you're talking about, must have unique values, right? So in either of this one, we can see none of them have the unique values, not the roll number, either not the project ID, right? So if you will try to, let's say, merge with student, if you try to merge with the student, you can see that there will be a single row, let's say for the student, and in S1 or say the S2 and S3, right? Looking at this part S3, so S3 have values P2 and P3, right? So P2 and P3. So two values in a single cell, obviously not the database constraint says about this, right? So atomicity is not followed. So that's why we cannot have this one. Since we try to, merge in the same way in the project one, we can see that in the project P1, we have S1 and S2. So S1 and S2, that's not possible. Due to this reason, always remember in many to many relationship, we cannot merge this enroll table with either of your entity set, right? So here, the minimum number of tables will be equals to 3 only, it's not 2. We will have to maintain this enroll table plus the entity set student and the project, right? So due to this reason, we can say that in MN relationship, we cannot have, a merge table formation, right? So let's try to solve, understand this with the help of an example. Let's say we have entity E1 related with relation R1, something like this. Let's say entity E2, right? So this is, let's say, one formation. set that we are having. Now, in the same one, let's say we have relation R2 as well, right? And this R2 relation is also with this given, right? So the entities are related, in a more than one different relations, that's a possible one. But the relationship is one to many and many to many here, right? So we need to identify how many minimum number of possible tables are there when we convert this ER model into a relational model, right? So obviously we know we will have the before converting that, let's write down what are the tables we have. Possible number of tables we have E1, we have for E2, we have for R1 as well as for R2. Right now we have four tables, right? But as per we have seen, right, in this one to many, this part, right, we have seen that R1 can be merged towards many side, right? So this R1 table we can collectively merge all together and we'll have one E2 R1 table. This is the merged one, right? So E2 and R1 can be merged into one table. But now look at the R2. Can we merge this R2? No, probably. Why? Because there is many to many relation. And right now we have seen we cannot merge this one with either of the entities, right? So we must have to maintain this R2 relations separately. So how many total minimum number of tables we have? Right? It's not four, right? It's three here. One is E1, R2, and E2 R1. These are the three minimum number of tables, right? So this is what we have seen about this one relationship we have in ER model, right? Okay, let's see about the partitions at the same point of time, right? We have something called partition in your ER model, right? So, so no, not the partition, it's participation. Participation, right? So how one entity is, participating with other entities, right? Okay. So basically, in your database, right? In database, we have several participation constraint, right? We have certain participant constraint means what basically it means. Before that we just try to understand. So far we have seen about the types of relation, that is one to one, one to many to one, and many to many. But there is a problem, right? So right now we have seen like student and there is a enrollment in the project, right? We have said that when we have the one to, let's say when we have one to many relation, we said that a student can be enrolled in many projects and a project can have exactly one student, right? But we didn't said that is it possible that every student must be enrolled in the project? No, we cannot. We are not able to represent this part here, right? And also, can we say that is there any project which is there is no student inside the project? No. So this information is basically not covered in your relationship so far we have done, right? So just think of a real life scenario, right? You can say that, let's say um, we have the student, right? And we have, let's say, the professor, not the project, it's the professor, the real life scenario you can see, right? Let's say we have the PhD student here, right? So students works under the professor and we have the students, those who are doing PhD, right? So so far we have what we have seen is, can we have, let's say, one student, right, and is more than one professor, under more than one professors, right? Or say the professor is having exactly one student. This is so far we have done. But we didn't said that a professor can have, let's say, at least a professor must have at least three students, right? Or we can say that at least three students should work under the same professor, right? Or we do not have such constraint like a professor can have at most 10 students, 10 PhD students, right? So some figures we have not, represented so far in your relationship table. And that's what the participation constraints comes into picture in ER model, right? So what participation constraint is, basically it specifies whether the existence of one any entity depends on being related with another entity via a relationship type, right? So these constraints specify minimum and the maximum maximum number of relationship instances we can have, right? That each entity can or say the must participate, right? So this thing we haven't covered so far in our relationship table. In this one, in participation, before that, we have something called minimum cardinality, right? We have something called minimum cardinality. And what's that? The minimum cardinality, it is the minimum number of entities, right? The minimum number of entities to which an entity must relate to through a relationship set. That's the minimum, right? And the same we have the maximum cardinality, right? What is the maximum cardinality? The maximum number of entities, right? Maximum number of entities to which we can entity may relate to through a relationship set, right? For example, let's take E1, right? E1 entity we have, and we have the E2 entity, and anyhow they're related with R, right? So how will, before that, how will represent this minimum max? We generally used to write something like this. This is for the E1, and for E2 we write here minimum and the maximum. If I write like 0, 2 here, right, and if I write 3, 8 here, what it means, right? It means what? The E1 entity. Let's say E1 is your employee, right, and E2 is, let's say, the project one, right? Employee project. Just try to understand this with the help of example, right? Real example. So what it means, the employee said there are some employees here. If you talk about the minimum values, there are a few employees who are not under any project, right? But at the same time, when we talk about the maximum, it means what? A maximum of 2 employees can work in a project, right? This is how we have the maximum and minimum values in this one. But when we talk about here, project E2, it means what? In a project, when we talk about the minimum, in a project, a minimum of 3 employees can work, right? And also the maximum when we talk about, we say that a maximum of 8 employees can work in a project. This is how we read, right? So when we talk about the participation here, how we will understand the participation. See here in this one, E1, right? The minimum value is 0, right? The minimum value is 0. It means what? There is a possibility like E1 or say the employee is not related with E2, and that's what when we have the minimum 0, right? So this shows what there is what? Partial participation, right? There is a partial participation, because when we have the 0, there will be no participation. But when we talk about this project side, right, we have, anyhow we can say that there will be a relation with employee, means there is no minimum value to 0, right? Anyhow the project will related with the employee. So this is what total participation, or say the complete participation. And we used to sometimes represent this by double line, that's for total participation, and single for complete participation, right? Okay. So we participation, we have total participation, right? What's the total participation again? right? An entity set is said to have, basically we say, the total participation if each and every entity, right? Each and every entity set, every entity set participates, right? Participates, whatsoever we have covered till now, participates in the relation, right? In the relation, or what we can say that uh, the minimum cardinality, right? So for that's minimum, right? So minimum cardinality of entity set is one or more. It's not zero. It should not be zero. It's one or more. Then it says it's a total participation. Since if you write this one here, it will become the total participation here, right? And the same for partial participation, right? In partial participation, an entity set will be having the partial participation, right? If there is at least one entity in the entity set, right? At least one entity in the entity set which does not participate in the relation, right? So at least one entity in entity set, right? Uh, which does not participate, right? It does not participate in the relationship set, or basically, in other words, what we can say that the minimum cardinality, right? Minimum cardinality of entity set is zero or more, or say the zero, basically, like zero. When you say the zero, it's partial participation here, right? How we represent in this one, we can say that. But see, if we write partial participation and total participation, it's still, it doesn't provide you the complete information. So it's always better that we write this format here, this one. This is understood. With this one, you can understand that obviously this is either partial or the total participation by looking at the figure. But also it also says that what the maximum values we can have in the participation, maximum of 8. Of what's the minimum of values we can have, right? So this is more informative rather than just writing the total partial participation, right? So this is what we have covered so far in participation. And in ER model, we have seen one to many, many to one, and many, right? So, okay. In the next one, probably we will solve a few questions, right? And then, yeah, we will move on to the next topic. Okay.